don't you give me your black magic. 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 Don't you give me your black magic.
There's no denying what we want. There's no denying what we want. Playing games, no. There's no denying what we want. There's no denying what we want. Playing games, no. There's no denying what we want. There's no denying what we want. Playing games, no. There's no denying what we want. There's no denying what we want.
About to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free with me. Looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free with me. Be free. Be free with me. Be free.
welcome to the next episode of Let's Code. Dear viewers, glad that you joined us today. And with us, I mean Russ Miles and myself, Mr. Chaos Engineer, or Mr. Chaos.
One of them. One of them. There are quite a few of us now. So yeah, it's a growing discipline. So
there's a roadshow which happened this week where you were touring the cities in Germany and Netherlands, and I grabbed the opportunity this morning and just asked if you would like to join today.
Yeah, it's a great pleasure.
And you said yes, and I'm very happy about it. So would you like to introduce yourself to the audience, who you are and what you do, and what this is all about with chaos engineering?
So for those of you that don't know me, I'm quite noisy usually at different conferences around the world, but I've been working in chaos engineering for a long time now. I've got a startup called Chaos IQ, where we back the free and open source Chaos Toolkit project. And our take on the world is that chaos engineering should be for everyone. It's a powerful discipline. It's up there, in my opinion, with the sort of developer discipline like TDD. It's something we all should be thinking about. We all should be have the tools that enable us to do it. So that's where I am with things. I've just finished a book.
Oh, awesome.
Shameless plug for the book there. I've just finished a book. It's gone into production now for O'Reilly called Learning Chaos Engineering. So
awesome.
That's going to be hopefully on the shelves sometime in August, I hope, if I pull my finger out and actually get it finished, production-wise. So yeah, it's interesting times.
Great. So what's the intention of chaos engineering? What's the idea behind that?
So there's a great document out there called Principles of Chaos that describes to me the discipline of it. But I have a sort of working version of it, if you like, in terms of how I think about it, which is chaos engineering does, for me, one task and one task really well. It helps me surface evidence of dark debt. Okay, so it's surface evidence of weaknesses in my whole socio-technical system of production or staging. The idea is that inside any system of sufficient complexity, there will be this manifestation, this emerging manifestation called dark debt. And we can't design it out up front. You can't sit there with a whiteboard and go, oh, it will be there. We'll design it differently here. In fact, many of the mechanisms that we apply to a system, such as circuit breakers, might, when they work together, end up causing this dark debt manifestation. And I think that dark debt is it's a collection often of weaknesses in the system that are ready to bite you at some point in the future. It's the sort of thing that causes a system failure.
So it's maybe in other words, it's these events that get you out of bed in the middle of the night because something happened and it's not running and you don't know why. So it's maybe a toolkit to provoke these kind of scenarios so that you can think about that before and fix it.
That's exactly it. I mean, it's the idea of we can be proactive and surface these weaknesses in as safe a way as possible, in a controlled and safe, as safe as possible environment, and we can then learn from them and overcome them before they hurt our users, before they get us up at a stupid hour of the night. So yeah, that's what it's for.
Awesome. And today we would like to learn how that works, because this format is called Let's Code, not Let's Talk.
Yes, so, I like that. Let's do this. Let's do this.
We would like to get our hands dirty, maybe even in the end to target our poor little wobblehead application.
Absolutely. We'll give it a go. We'll give it a go.
Break it. So, ready to switch to your desktop?
Absolutely.
Okay, awesome. And let's take a chance to greet our audience. So Kevin is there, Mr. Test Containers. So you had the challenge to install non-free codecs to see the live stream. This is thanks for jumping through the hoops, Kevin.
Yeah, thank you. Thank you.
That's a challenge, but nothing I can do with anything about that. I'm sorry. Thanks for watching. So if you have questions, please feel free to comment in the comment section. I will keep an eye on it while you
show what we've got.
Show what's going on. Yeah.
Okay, so there are many ways of doing chaos engineering, but the way that I tend to do it, obviously, is with the tool that I've built, which is the Chaos Toolkit. So completely, that's my bias. But that said, it's a very simple thing to get started with. People are using it in very powerful and interesting ways beyond getting started. But all I'll probably have time to show, I think, today is the first few baby steps that you would use.
Okay. Yeah.
So just to introduce it quickly to give us some context, number one is a command line interface. So it's not anything dramatic. We're not going to see beautiful UIs or anything like that, but we are going to see the sort of things you'd expect from CLI. And
I think we all love CLIs.
I really do too. And it's amazing how many things you have to get right to do a good CLI. It's been a fun experience. But it's written, first of all, I have to say, it's written in Python. So we've had people ask for a Golang version. It's not there yet. The Python version, we think, is it's the most apt environment to actually do this sort of thing. I'll try and explain why a little bit. But the first thing you need to do to get up and running is have a Python virtual environment. So I've got one already enabled. I use something called a virtual environment wrapper, which gives me this command work on. Hopefully people can see that on there. Let's give it a bit more space. Can't do that. Clear that down. And then hopefully if I work on, you'll see what I'm doing. So work on, and I've created a virtual environment, Python virtual environment called Warble. So you can see it's turned on because you get that little thing on the left. So if you're not familiar with Python, that's at least started. And when you first create your Python virtual environment, there'll be nothing in there. So the first thing you want to do probably is to install the Chaos Toolkit, which is simply done. -U is a habit of mine. It gives me the latest version regardless. You don't have to use that. You shouldn't need that the first time you do it, but it's a complete, it's almost, I typed it without thinking about that. So just to let people know.
If anybody, it should be you to know the latest version of the Chaos Toolkit.
Yeah, it is. And actually, if you run the Chaos Toolkit and you haven't got latest version, it should tell you. So if we do now, we've installed it. If we clear things down a little, and if we do chaos -help, we should see that we've got the command in there. And I'll just quickly walk through the bits and pieces it does, because we're only going to demonstrate probably one or two of these things. But there's a bit more to it. First of all, the thing we're going to run is run. Run actually does validate as well. And what run does is it takes a specification of an experiment, which we'll see in a minute, and it does that against your system. So in many respects, the Chaos Toolkit is nothing more than taking an experiment and orchestrating it against your world. That's what it does. So leaving run behind, discover and info, those are about creating experiments. Our experiments are written at the moment in JSON or YAML. We'll see that in a minute too. The discover is something you can point at system and say, tell me what's there. And it will come back with a document, again a JSON document locally, that will say, this is what I found.
Cool.
And in it will then say, okay, take what we found and create me, or begin to walk me through a process to create a new experiment. So but they're there to facilitate that. They're getting more and more advanced over time. Right now they're pretty rudimentary, but they're getting better pretty soon. So we'll leave them alone for a minute.
The evolution of the kit.
Oh, absolutely. But the one we're going to look at, I think, is most important is Chaos Run. So if we do Chaos Run, actually clear down first. Clear. Chaos Run. Hold on that one too. We can see what we're doing here. So we're going to Chaos Run, and then we give it the experiment that we're going to execute, which we'll see in a moment what that sort of thing looks like. When an experiment is executed, it produces another output, another document. I should warn you, it's not a nice thing to read. But it's called the journal, and you can point it somewhere and create your own journal if you like. But by default, you get a JSON document that is called journal.json. When you get that out, you can then convert that into something other humans might be able to read. But that's the raw capture of what happened when we executed the chaos. Things like no execute. I should be more accurate here. Execute turbulent conditions. Yeah, it's the appropriate statement, I think. So okay, at the moment we've got the wall hat demo running here. I think it may even be executing, maybe not yet. Is that the whole thing, or is that that's the database? So we should be able in here run somewhere around here our Rollback web, and whilst it's running that up, I'll just open up a new screen, show you what it's actually got in it, because we've added a few pieces to enable chaos against what I call the application layer. So we do show in there, do something like recognized. Okay, code that. So what we've added is a couple of things. we've added, find it, this piece here first of all. Can people see that? Great. So what we're doing here is we're introducing a library, which I think you may have spoken in a previous episode about, maybe.
Not yet. No.
Oh, okay, great.
It's completely new.
So this is Chaos Monkey for Spring Boot. You can do chaos at many different levels in a system. You can do it at the infrastructure level, so you could look at virtual machines, you could look at the hardware, networks, that sort of thing.
So could you simulate like a full hard drive
Yes.
or memory exhaustion?
Yes.
Well, okay.
If you can imagine it, and perhaps if you've experienced it. By the way, I love the fact that we've renamed outages to surprises, which
awesome,
I think tells you what they really are. I mean, outage, when someone says to you, why did that outage occur? You're tempted to try and answer the question. When someone says, why did that surprise occur? That's a meaningless question. Because it's a surprise. So you can dig into it, you can try and unpack it, but it's less blaming. I like that. So anyway, right, so we've turned on what I call an application level facility for turbulent conditions here, and that's the Chaos Monkey for Spring Boot. It's a wonderful library that Benjamin and the team here have created. And what it does is give me an ability to say, take this application and ask it to perform slightly oddly. So I can inject conditions between the different layers in the application and say, right, if I'm calling a RESTful API, I want to introduce latency that looks a bit like this here at the application level. One of the places I've seen this sort of thing most useful is when you don't have control over the infrastructure and you don't have control over the platform. This is really useful for things where you're running perhaps on Lambda or a system that doesn't give you that lower level access. You can still ask yourself the interesting chaos related questions.
So we're deploying to Heroku, and there that would make perfect sense.
This is where you do it, because you can't get underneath. That's it, exactly. So we've turned this on by introducing the dependency, a very Spring Boot thing to do. I've also started to begin to try and turn on things like the Actuator, because we need a mechanism to talk to it to turn the chaos on from the experiment. So if we go back to our terminal, hopefully we have something. There we go. So we can see we've at least enabled it. It's exposing 2 endpoints under Actuator. We probably need to turn a few more on to be able to access everything.
Well, we have to add one thing. So it's not usually turned on by default just by adding the dependency, but you have to activate the Spring profile.
Let's have a look at that quickly, shall we?
We did that in the application properties.
We did. So if we go back here, we can see those properties. We added it here.
So it's not a problem just to having that dependency, even if you deploy to production, as long as you don't turn on the profile, the Chaos Monkey will still be in the cage.
Exactly. And actually there's another way of turning it on as well, where I think you can, if you run a Java command, you can actually say, go and get this and add it at runtime. So you don't even have to package it with it, which is quite nice. So that's given us the facility to use it, but right now we've got a challenge in that we can't talk to it to turn things on. You have to enable the actuator in order for us to be able to operate the chaos, because at the moment it's not enabled. We can see that, I hope, if we go to localhost 8080 and actuator. Yes, we can see we've got a few commands in there, but we've only got, actually if I zoom in a little, we've only got health and the actuator itself. So actually we don't have access to the Chaos Monkey for Spring Boot yet. We kind of have to turn that on. The reason we have to turn it on is the Chaos Toolkit will want to talk to the Spring Boot app to say, do it, do this, do that. You could do it all yourself. Once you turn this on, you could command this yourself by putting RESTful, requests in curl, whatever you want to use. But we've automated this into the Chaos Toolkit so that you can have an experiment that says, right, turn on the Chaos Monkey. Now set up this chaos. Now,
awesome. So it's like a you can script the chaos.
Exactly what you do. You can see you can have a complicated experiment if you choose to do so. So we haven't got it at the moment, but I believe there is a shuffle to turn this on. So I'm just going to make sure. Well, you can see me now, see just how raw and live this is, because I'm going to try and figure out how that's done or remember how it's done. I have to warn you, it's been a while since I've done a lot of Spring Boot stuff.
There's something documentation that you just showed for the Chaos Monkey. How to do that. I think
it's the management endpoints that I ended up having to turn on. There we go. So I think it's that beast there. Let's find out. This is about as live as it gets. We'll pop those in and we'll see if we get lucky. So we're just it might even do it for me. So we're gonna try it anyway. And how smart these applications are. I'm just getting to know the Warble app, so this could be a lot smarter than I'm giving it credit for. So hopefully this will turn on quite a few more of the actuator endpoints. Let's see if we get them. So we go back here, we refresh. Well, hey, now you'd never want to run this many actuator endpoints in production necessarily, but that's an interesting point. So I often get people ask, do I run chaos in production only? And to be fair, in production is the best leverage to learn. However, it's also everyone can hear you scream in production. So my advice is to go for small blast radius experiments somewhere else before you go to production. Don't make production your first experiment, perhaps. It's a good idea. So we've got actuator running.
Maybe also fix the obvious things first before you start with the chaos.
Yes. I mean, you can find you can discover a lot in staging.
Yeah.
And then when you go to production, you might find more. But generally speaking, let's find it somewhere else first if we can. And the idea is, as long as you surface the evidence of the weaknesses, then you have the reason to improve the system. Sometimes, and it's a fair argument, you could say that if we surface the evidence in production, that gives us absolutely every good reason to go and overcome the problem or make a serious decision that we're not going to overcome it.
Yeah.
When staging says it's got some evidence of a weakness, it's slightly more ignorable. So maybe, I don't know. But anyway, there's a fine line between having leverage and reason to improve the system, and oh my goodness, we've just taken production down, which has given us all the leverage and reason, but now we're losing money. So okay, so that should be in there now. So we should get lucky that we should be able to go to this system and actually do some chaos. I'm just going to see if those links work. So we can see the properties here. Let me just zoom in again because it's a little bit small for everyone. These are the things that have been enabled as what we can do to our system. So we've got a latency assault that is actually turned on by default, which is interesting. I didn't necessarily configure that myself, but that's what's in there. And we have a number. We could do an exceptions active assault. We can do a kill application active. Kill application is simply you can go in and make that Spring Boot app die. So that's one of the first ones we're going to try and do in a minute and see if we can get that working. That will be fun. And you can see the way it works is it uses Spring AOP to get in the way. Right. So one of my first books was on aspect-oriented programming. So I'm not expecting everyone to have done this before. But the whole idea is you can intercept things as they go through the application. And so this is going to intercept around, at the moment, service invocations. So it's going to say when we try and call service, we could introduce latency if the other conditions are appropriate. Okay, so that's our little application set up now. I'm assuming we can still talk to it normally. So we'll try localhost 8080. And it's all there. I don't think there'll be any problems with talking to it.
It's already saying something that there's some latency with it, or
it's mostly initializing the dispatch.
Okay, no, that's something else. Okay.
Yeah, I think it's working as expected at the moment. I don't think we've done anything that it'll necessarily cause a problem.
Okay.
Right. So at this point, you could go in, and if you look at the
questions yet from
questions. Okay, just a few more clarifications. That's good. So if we go to the Chaos Monkey for Spring Boot, here we go. You can see a lot more about what you could turn on and off and how far you could go with the system. So if we look at things like how does it work is an interesting explanation of how we intercept and put and inject the turbulence. Now, the Chaos Monkey Spring Boot, like a lot of different, I would say, turbulence-inducing chaos tools, is targeted at doing something to your system that is hopefully going to highlight a weakness. What it doesn't package is the concept of an experiment. You can turn things on, you can assault things, and then you can talk to it, but that's where its remit sort of ends. And there's a lot of tooling like that. So if we look at things such as Pumbaa, which is another one, and not Pumbaa the Lion King, I saw that come up. If we look at Pumbaa Chaos, I hope it will come through. Here we go. If we look at Pumbaa, it has similar properties. It's eventually, if it loads up, here we go. Has similar conditions. It will go ahead and change the conditions of what's going on in your system. It'll inject turbulence, essentially, so you can kill containers You can emulate a wide area network.
Oh, okay.
This is a classic case of most tooling at the moment works at this level of what can I attack, what can I interrupt, what turbulence can I inject.
So that's for Docker containers?
It is.
Oh, okay.
Yes.
Awesome.
Very powerful tool.
Yeah.
And we integrate with that too. The Chaos Toolkit's a little bit different.
Mm-hmm.
In and of itself, it doesn't do any chaos, which sounds odd, right?
Mm-hmm.
Got a Chaos Toolkit that doesn't do its one job. But let's have a quick look at it. Here, we go to chaostoolkit.org. The diagram is the only thing I really want to highlight here. Because the whole purpose is that you use the Chaos Toolkit to take an experiment and orchestrate it against your. One of the community actually turned around and said it's kind of like Terraform, but for chaos.
Mm-hmm.
We use a whole collection of drivers that do the work. And one of those drivers is the Chaos Toolkit Spring driver, which uses the Chaos Monkey for Spring Boot.
Okay.
So one of the things we'd need to do, just in order to get this working, is we'd have to install that driver. And one of the ways of doing that, if we can find, so we were in there. Let's do T. Let's do show again. Okay, so we go and work on our wall. Excellent. To install the driver, we do pip install -u Chaos Toolkit. Oops, I'm tight. Wow, you really get it live here, don't you? Chaos Toolkit Spring. Okay, great. So that's installed now, the Spring driver. I think we can see that as well. If we do chaos-help, help, then we do chaos info. I think we should see it in there. It'll only work. Let's do the right command. It's just me eating up time now, that's what I'm doing. Okay. So if we do core, let's do extensions. So chaos info extensions. Unfortunately, I can tell you why it doesn't show up. I think the chaos, so if we look actually, if we go and look at, if you go to GitHub, Chaos Toolkit Incubator, this is where the majority of our drivers live, our plugins, our drivers, and other extensions. And in here will be Spring. There we go. So you can see how it's implemented. It's nothing dramatic. It's all just a Python module, but it won't have overridden the feature it needs to appear in there.
Okay.
So I'll tell you what we're going to do right now. Just because we're here and we're live, why not create an issue for that? Add info discovery to the driver. There you go. You don't get much more, and I'll do it. How about that? Label. It's not really a bug, but it's close. There we go.
Do you know the maintainers for Pumba as well? Because Kevin Kevin is a Mr. Test Containers, and he said that they have an issue with Pumba because Pumba is also killing the test containers Docker container, which they actually need to run. So
it kills itself. That's true chaos. I don't know him personally. I would imagine it has got an open issue on there. Sadly, no progress on it. I've just seen a note from Kevin. Thank you for that. No, I don't know how. I mean, I can only imagine we can upvote it until it happens. But there's no way of specifying filters, which I think is a challenge. However, Pumba is sort of expecting sometimes to run outside of the influenceable set of containers. So, yeah, I imagine this is one of those interesting edge cases where actually it feels kind of core edge case. But yeah, maybe someone from the Pumba community will watch this and give us the hint.
If you put the URL to the issue here, Kevin, then people can vote on that. Yeah,
absolutely. Okay, so and if you want to vote on this one, then you're more than welcome, and I'll get that fixed probably today if I get a moment. Right. Anyway, back to here. So we can now run chaos against our running Warble web application. To do that, though, we need an experiment.
Wobblehead is the librarian from Discworld.
Okay, Wobblehead.
Yeah.
Okay, brilliant. Do you know what? I've not read much Discworld as I probably should. Big fan of Terry Pratchett, but no, I haven't read enough. So yeah, that's a little thing I'll take away. Is I need to read the stuff more. There's nothing like really good geek references in your code bases. It's beautiful. Okay, so let's open up what an experiment can look like. Now, normally I'd write it all from scratch, or I'd use the Discover and Init workflow. We're not going to do that here because honestly, it's going to be taking a little while to do it. But what I will do is show you what an experiment should look like. So let's go and have a look at one that is in this directory as well. Hopefully, commit it into the code base straight after today. Even if we don't get a chance to do it during. Let's open up here. Close all this down. Okay. We've got our first experiment in here. Hopefully everyone can see that. What's it look like? That looks pretty good. Let's maybe open that. Maybe go bigger and bigger. There we go. That looks pretty big. Please let us know if you can't see this. If you can't see this, maybe you can't type.
Let your optometrist know what was it?
Yeah. Maybe an eye doctor or whatever. Yeah, absolutely. So, first thing to point out, it's in JSON. It could be in YAML. Pick your poison. Not a big fan of either, but that's the way it is. We start off by version. That's really just the version of the definition that we're writing. Title usually says what we're going to look into in a kind of a summary sense. So we're going to trigger service dependency death, and the idea is that we probably then look at the rest of the system and see how that influences it. Description is something that gives people a little bit more information about what you're going to do. Tags, entirely optional. We've said we're working on a service and we're working with Spring, but it could be anything you like. There are a few other things you can add as metadata into your experiments, but we don't show them here. There's things what I like to point out is something called the contribution block. That's a nice way of saying that this experiment explores things that matter to this. So in contribution, you might say it's a high contribution to security, whereas a medium. So the value, it's a bit like BD. We'd say this is why we're bothering to do this. The first block you usually have, although it doesn't have to be declared first, I should point that out, is the steady state hypothesis, which is the first piece of jargon that comes from the chaos world. The idea of this statement, this block here, is it defines normal in our world. What is the condition? What will we recognize as normal? And here we've declared normal as being if we can hit this URL, which is our application, our little hat, and we get back a 200, which could be a list of codes that come back, then we will declare that the system is healthy as far as we're concerned. And actually, I'm usually avoiding the word healthy because the system health could be bizarre. It could be things going down, coming up, or whatever. What it is system normal. It's the better definition. And that title doesn't have to be at the bottom. It can be at the top. It's usually better to have it up here anyway. There we go. Live fixes. That's what you want. Right. Next thing, I should point out, the steady state hypothesis could be many probes. It could be looking in many different directions on your system. The next thing we have is the method. The method is usually its only job is to introduce turbulent conditions, to set up the thing that you want to explore. So in this case, what we're doing is a few steps. We're doing a few what we call actions. Actions change the system in some way. Okay, that's the intention of it. So what we've got here is we are calling a Python method inside that Chaos Monkey Spring driver. We're calling from the Chaos Spring Actions module the function called enable Chaos Monkey. So this is turning it on properly, so that the way because and actually what happened here is it's probably already turned on as we just saw. But it'll still
doesn't hurt.
Doesn't hurt. Doesn't or shouldn't hurt. We'll find out in a minute. Then we configure the assaults that can be turned on. So what we're doing,
that's what we have seen, the actuators, and with this you can configure the kind of misbehavior for your system. And, examine if it's still normal or if it starts misbehaving.
Exactly. So you could, we could have a very complicated method here that at different times does different things to the system. So it can be interesting in that regard. Here we're being pretty simple. We just turn on a particular assault. And in this case, we're actually turning on the kill application active assault. Okay. Once again, we're calling the methods inside the Python in order to do this. Underneath the hood, we'll have a look at code in a minute. It doesn't do much. It just calls the APIs. So, and you'll see that with a lot of drivers. They just tend to make a simplified bridge to the system. Then we trigger the kill, which is actually where we hit the endpoint and it's gone. It's basically looking at it and going, it's absolutely gone.
Because the Chaos Monkey needs something to to work on.
We need to cause it. That's the way. So this has said we do want to enable it here, and then we've said this is going to make it happen. And then the way that a chaos experiment is run, the first thing we do is execute this steady state hypothesis. We use that at first to say, is the system recognizably normal? If it's not recognizably normal, don't do the experiment, because you have a dirty Petri dish problem. There's no point doing it. Then we inject the turbulent conditions, which is the method. And then, and you won't see any asserts here or anything else, what actually happens is we run again the steady state hypothesis.
Just once, or do you continuously?
Only once at the end. Okay. Now, to talk about the continuous, there's a whole issue on whether we should be running it in between or anything like that, or continuously. So that's being discussed. But at the moment, the simple option that we have right here is make sure the system's normal, do the injection of the turbulent conditions, compare normality to what we now see.
Okay.
So that's, if you like, that's our test assertion, is the system, we believe the system will still be normal, even though we've done that.
Let's see.
In this case, probably not. But that's the conditions of what we might work within. The one section I just wanted to pull out, which we don't have anything in for this experiment, is the rollbacks. In rollbacks, you normally try and put things back the way they were compared to what you've damaged, right? The things you know you've damaged in your method. So here we could put a piece of code in that says, do you know what? We know we've killed the app. Maybe we should rerun it. And we could do that. We could have an action in here that was run a process call to restart the app. So it's actually quite trivial to do. We could put that in. So
and do you give the application some time to recover until you killed it, or do you just kill it and then check back immediately? If
at the moment, it's immediate. Okay. We could put a delay in here, so we could say do this. This basically is invocation of the application to cause it to die, and then
I'm just being nice on the application, right? I mean, the customer could hit the application at any point, so the nice thing be immediately right after it's been killed.
The nice thing about this is that a nice thing about the Chaos Monkey for Spring Boot and this particular assault is it does die pretty quickly, so we don't wait. It's pretty much on. So it all works. So let's roll the dice, the demo dice, and see if we can get things actually happening. So we've got the application running. If all goes well, touching wood somewhere, we should see it die. And then we'll probably see how the experiment reports that, hopefully. So we should be able to do chaos run, kill, experiment.json. Now, the challenge here is if it can't access the actuator for whatever reason, security reasons or other, then this is why this might go wrong. Just pointing that out. So we'll try it. Oh, it didn't kill it. That's interesting. So we just walk through what we've seen.
Okay.
We've validated the experiment syntax, which seems to be okay. We go ahead and trigger dependency death or application death in our case. We've configured the assaults, which apparently worked. Seemed a bit quick, but it did seem to work. But the application is still ticking. So there's been something that's not worked. There's been something that changed in the meantime. So unfortunately, it looks like it's going to fight me in this regard. Although I can show you it working against a different one that we then need to look at how it's working in here. So, but you get the idea.
Can we try it manually to see from the actuator endpoint if this kill switch is active?
Yeah, we could see if it's still there. It's not that one. Where is it? Not there.
Yeah, no, that's the application.
We hit the actuator. And we hit that one. So it has turned kill application on. But it looks to me that if we hit the root, it's not killing it. I imagine before, by default, any URL would have caused it to die.
Yes, and I have also seen it die when I tried that earlier.
Okay, so what are we missing would be the question.
I don't know.
Oh, I don't know either at the moment. So let's have a quick look at what the docs say. Always revert back to the docs. So
I wasn't using the actuator because I couldn't get that to work. So I was using the application properties to enable that.
Right, so you were having it hard-coded set up on it. But it is, I mean, clearly it's turning it on.
And I didn't see the Chaos Monkey output in the log when we started that now?
Let's have a look and see, because that may be a different issue, right? So, let's
So
have a
the
look.
actuators are there, but it's maybe it's not enabled. The I don't know.
It certainly was.
Oh, yeah. But then you restart it, right?
Yep. But this is the restarted one.
Oh, okay.
So it should be, otherwise we wouldn't see the actuator reporting it's been turned on anyway. Trick here is what causes death.
Yeah.
So what's actually triggering it? Oh, that sounds bad, doesn't it? But let's have a look at the documentation to see if we can do the same thing that all you people online will be doing anyway, which is looking at exactly how.
So maybe our audience is spotting something.
Yeah. Does anyone want to help us with this? So, acular assault. Okay, it's not in metrics. When the configured methods are called. So the trick here is...
so you probably have to turn on service or...
So we have Benjamin, come in a second. Right, we're going to be joined by Mr. Chaos
we need
Monkey
to help.
for Spring Boot.
Okay.
You get to join, my friend.
The Chaos Monkey is not killing the application.
You might need to come down a little, otherwise you look kind of beheaded. So, what we've done...
Oh my god,
Yeah. Not on the spot at all. Is what we've got is... we've turned on the Chaos Monkey, as far as we can see. We're exposing all the right endpoints to allow us to do it over Actuator, which is what the driver in the Chaos Toolkit needs.
Yes.
So we do have an experiment that has worked before against other versions, potentially, of the Spring Boot Chaos Monkey Spring Boot. We enable it. That seems fine. It is enabled, although that is the wrong URL, so it doesn't matter one way or the other. We know it's enabled anyway. Actually, we're in the wrong place. Hang on, we're in the wrong. I think we're in the wrong.
No, 80 was
a code. Hang on. Let's make sure we're looking at Warpath. Right. Now we're back in that place. So steady state hypothesis, as per usual, just hits the application. Yep. That's fine. We've got the actuator. We enable it. It seems to be okay.
Okay.
How we? Then we configure the assaults, which is turn on kill.
Kill application, of course. Yeah.
Okay. We then try and kill it by talking to it. It doesn't want to die.
Which method is responding to this endpoint? Is there a special method?
Let's have a look. So if we go to the code base, we're inside the web application, which hopefully, if we scroll up a little bit, we can get to.
Do you have to turn on service or
might need service in there? Is that the default?
I'm not sure. That's why I would like to look who's responding to this request.
So I'm guessing we hit root. Do you know which controller it is that we?
Yeah, that's the booklist controller.
Booklist controller.
And so it's annotated by Edge controller. Okay.
Ah,
no, the root is actually not the booklist controller. That's the navigation. Probably navigation.
Yeah.
Okay. Edge controller is enabled. And that's also enabled in the Chaos Monkey configuration. The watcher component, the watcher component at controller is also enabled.
Probably not.
Probably not.
So
let's turn it on.
This is why we have the genius in the room.
Okay.
So let's make sure we know where this is. So this is the piece.
Yes.
Okay. Let's make sure that's the piece. So if we go back to our application properties, I guarantee you that's not turned on, because I certainly didn't add it. So let's turn that on. So we come away from the actuator.
Do you have to do that there, or could you also do that in a JSON from the experiment? I'm currently preparing the next release because my colleagues of Frankfurt have enabled or have changed the behavior of a watcher component. So we are now able to change it at runtime. You don't need to restart the whole application.
So next release, update the driver, and we're
you don't need to.
Or just the same, just
but you could extend it, because now you're able to turn it off during an experiment if you would like to attack a watcher component annotated with add controller or add service, whatever.
Nice. So it's actually in the setting assaults that you turn things on.
In setting of watchers.
Setting of watchers. Okay.
So it's a new endpoint in your case for the Chaos Monkey.
Okay, great. Okay, so I'll be watching that to update it.
Yeah.
So we've done it hard-coded, old style for now.
Yeah. Restart the application.
To restart the app, because it's the way that it works. So
and we have LED lights.
Yeah.
Just imagine we have.
Not like last year. For those that are watching, I'm going to take a photo of our lights so you can see this in a minute on live. This is some setup we have here. This is amazing. And that's what's right in front of me. They'll be coming out on Twitter soon.
Some behind us.
More lights behind us, yeah.
Okay, so I think
We
that's
started.
happy now. Make sure we've got the Chaos
Yeah.
Monkey Spring Boot coming up.
Which
Brilliant.
level did you choose? Attack level. Level 1, level 10. How many requests should occur before an attack will be?
Okay, let's have a look. So that should be defined in the experiment, should it not?
Yes. Level 1.
Level one.
Fine.
So every request,
Yeah.
that means.
Every request should kill it because
Yeah.
I wanted predictability.
First one.
Yeah, which is the only one. If we look at
Is
the
it-
experiment,
is it the
it's the
first
only one
or
we do.
Is it the chance to trigger it? Or is it, so
Is
if
it
you put
near
3
to
is it-
close? The first one. Really near to close.
Yeah,
It's-
but if you put 3, is it
Yeah.
doesn't trigger, doesn't
No,
trigger, or
no,
is it
no,
just
it's randomly.
Okay.
Because I have not a rolling time window where I'm counting requests and
Yeah,
to
okay.
do some percentage values. So I'm just nearly by 3 requests.
Okay.
Okay. So now we can jump over to hopefully here, and we won't see that because this said it was all surviving, which it did. So we'll try it again.
Not like expected.
I didn't expect it there. That looks like something happening.
Kill.
Boom!
Bam! Yeah.
Awesome.
So now
Awesome.
We
Yeah.
killed it.
we've got exactly what we wanted. So as Chaos Engineers, we celebrate failure.
Yeah.
Yeehaw! So the main one, yeah, exactly. Cheers, indeed. What we've got here is deviation.
Möchte den Stuhl nehmen.
I need to.
Thank you.
Oh.
You're probably good. Thank you for that, though. You're probably good. We might be able to release you if you want to run.
I would like to run.
Thanks for your help.
Brilliant.
Thank you.
Cheers. So, just to look at what we can see here, because at first glance it can seem like this is all a bit panicky. But what's happened is we've run the experiment. We've looked. It is a valid experiment as we had before. It's doing the steady state hypothesis is executed first. You can see that there. Steady state hypothesis is met. No deviations. We can continue the experiment. We turn on the Chaos Monkey. We configure the assaults, and then we trigger the kill. And when we trigger the kill, we then come back to the steady state hypothesis. Okay, as soon as you come back to the steady state hypothesis, we can't connect to it because, guess what?
It's killed.
It's dead.
Yeah.
And now we can see that we can report that the steady state probe is not in the given tolerance. It didn't get 200.
Yeah. So here it's kind of obvious because we kill the main application. But assuming that we just killed a microservice which provides some irrelevant data, so we would expect that the main application is still working, that not that just the data isn't shown.
I
Right,
can
so this,
show you an experiment that does exactly that.
Okay,
Slightly
awesome.
different system, but because we've got one service here, it's a little more harder to see that sort of cascading effect. But if we look at, there's another example experiment I've got here, if I can find it. Yeah, here it is. So this is the case. If I open this, right, let me look at the application. This application is a bit different. It's 2 microservices. One at the back end has the Chaos Monkey for Spring Boot enabled. One at the front end that doesn't. The front end makes certain assumptions that the back end is going to be there. And so what we do, the main thing to point out, I think, is the experiment itself. If we go and look at the kill dependency experiment, I'm going to make sure everyone can see this. It looks exactly like we've just done. There's nothing new here. The important thing is to note that when we do the steady state analysis, we do it against the front end service, the 8080. Okay, that's the thing to pay attention to. That's talking to a service running on 8080. But then we enable the Chaos Monkey, hopefully against 8090, which is the back end service. We're adding the assaults to the back end service. And then we trigger kill, which would go against the back end service as well. And then we look at the steady state hypothesis from the front end in. This is a classic example. Steady state hypothesis is a sample of the business characteristics of the application from the outside. Whatever you've done inside with your turbulence, with the Chaos Monkey for Spring Boot or Boomba or anything else, that's inside the world. And what you're saying is that your belief that you're testing with the hypothesis is that the system will survive it.
Yes, hopefully,
So Chaos Engineers, when they do an experiment, they start from, we believe we'll survive this. And when we deviate, when we run the experiment, we found that there is evidence that doesn't support our belief. Now, I do get asked sometimes, just a little aside, I sometimes get asked by people, if I know the system won't survive something, if I know, That word's always interesting. I know. The system won't survive. Should I run an experiment? This happened to me recently. Someone said, if I know this, system won't survive, this database going down, why would I run an experiment? And I asked them, okay, so that word no, do you really know? Yeah, I'm pretty sure. That's not no.
Sure, yeah.
That's not no.
Yeah.
One of the things that you would run a chaos experiment for, even if you strongly suspected the system wouldn't survive, is you would do it to give yourself evidence that supports your newfound knowledge that the system doesn't survive it. So what it gives, it doesn't give you proof the system's got a problem, but it does give you some evidence. Under these conditions, there was an issue. And then,
so I was quite sure that the bobblehead didn't survive and we killed the application.
That's fair.
But for the database, I'm not so sure. So what if we pull away the database while it's running? So maybe we can get there at the.
I could actually show you how to do it if you want. All right. So because it's Docker Compose down, right? It's
yes.
the database down.
Yeah.
Right. Let me show you. This is fun, right? If we go to Chaos Toolkit documentation, there are several ways of causing turbulent conditions. If we look at docs, let's go to the docs.
Would be the Pumba thing then, or
no, we don't even need that.
Oh,
we don't need. We could do, but we don't need to. It's entirely up to you if you want to use a full gamut of Pumba. That's totally fine too. But if we look at not the driver's reference, if we look at the Chaos Open API and experiment, and what you'll see here is a Python provider for it. And not Python. Let's look at process. So a process provider, I won't walk through all the docs there, but the point is here, you've seen so far, when we create an action, it calls a Python method and things happen. You don't have to do that. If you've got a script that causes turbulent conditions, we can just call that. And we do that using the process. So I need to remember how to write a process action because it's not something I do all the time. So let's take a quick look. I can just show you what it'll look like. If we go to GitHub, there's a little organization called Chaos IQ, which is my company. If we look at demos, here we go. I think in here we should find something that does something really rudimentary. If we look at our example here, file must not disappear. I've got a feeling something in it does process. Here we go. So we're going to steal this block. Copy and paste. It's the way the cool kids code. Right, we're going to take that. And we're going to take.
I have to laugh because when I started this show with Benedict, that was one of his mantras to never copy and paste.
I think it's an entirely admirable aim. However, Stack Overflow tells us otherwise.
Yeah, because you introduce always these little mistakes where you think it's the same, but it isn't. So
I agree. I agree. So what we have here is we have our application. This is the same experiment we just had. So what we'll do, we'll leave that where it is. We've got a weakness. When the application dies, it dies. You know what? We
knew that, yeah.
Okay, so let's create a new one. Let's just copy that over. So we're in the right place. It's here. Good. This is the right place. No, it's not. Always make sure you're in the right place. Good. This is our Warblehead app, as we can see. Warblehead YouTube. Brilliant. So we're going to copy kill over to, let's call this kill db. .json. Okay, now we go back to the code for it. We can close that down so we're not accidentally editing the wrong one because it happens. Kill db. Here we go. Right, let's kill all others. Close all. You know what? Open up again. Right, here we are. So we could go ahead and change all the stuff, but let's not do that yet. Let's do the thing. This is still definition of normal.
Yes.
Okay. We don't need the Chaos Monkey this time. We're not going to use it because it's database. Right. So what we're going to do is we're going to replace that, and probably replace everything else in a minute with that. Okay. We're going to kill off the rest of the blocks inside the method. Our method now is one thing only. It's an action. So it's going to modify something. We're going to call it killdb. Okay, it's a process, and we're going to try and run Docker Compose down because when you
I
launch
think
it up,
that's an argument to the path, right? The down.
The down might be. You're quite right. Let's do down. Let's try that.
And for the rollback, we then do a Docker Compose up again.
We could do. Let's do that too. Let's try and be a good citizen. First of all, we'll make sure this works.
Okay.
So let's try it. Let's jump over to the code base here. Let's go and run it. So we now can do, and I should point out it is running over here. So let's see if we get lucky.
Okay, yeah.
Okay, that's our database running in the
If we
background.
started the application itself again,
We-
after we killed it.
We probably should, shouldn't we?
Yeah.
Otherwise our steady state hypothesis wouldn't pass and we wouldn't do the experiment. So we'll give it a moment to do its Spring thing because it takes its moment. You can't rush Spring. You can't rush Java. It needs its time.
I still come from days where starting the application server takes minutes. So
Oh.
this is awesome.
I remember those days. I used to call them the WebSphere days. I remember them well.
Yeah.
Thank goodness for things like Tomcat and Spring Boot. Okay, so it's a better world. Okay, so now if we do chaos run, no, that's not quite what we're looking for. Chaos run, kill DB, isn't it? So let's see. So it's trying to kill DB. It's doing the Docker compose down, which I think takes a little while to happen. Give it a moment. Should we go and see if it's doing it?
Yeah, that's nice.
So it's gone down. Do you know what? Your application still seems to survive.
Yes, because we just hit the root control of the navigation.
Right.
Now we can try
Oh.
to call the book list, which actually calls,
Won't work.
shows the list of the books.
So our steady state hypothesis isn't good enough. That's what we've learned. So now is it book dash list or do you remember what the URL is?
Slash book list, I would think. Not sure
Well,
if it's an uppercase
we'll
L
test it.
or yeah.
Let's go and see. Well, first of all, we need to see if it fails. So let's go have a look at that first. So let's do that. A look. That looks like it's failing. So that's probably good.
Is the object not, can we start the database and try again?
We certainly can. Can do Docker compose up. We'll just zoom a bit on that so we can see we're doing something. So it looks like it's ready. Looks like it's happy. Let's try again.
Try with an uppercase L.
See what we can do. We can cheat.
Oh,
Shell books?
Yeah.
Book list. Boom. Having problem reattaching.
Yes, it has.
So this is a great experiment. Let me show this. So this is now what we've learned is that this URL is our steady state hypothesis. We didn't have a good enough one. We have now. This is important to us. This is an explicit measurement of business continuity. So we're going to drop that into here with the right capitalization.
Yep.
Awesome. So now when we run this experiment, we should find that it will kill the database and it will fail. It will be a deviation because that's what we've sort of seen already. But now we have an automated version. So what we can do is we're probably going to relaunch our application so it comes back anyway. So we'll bring it back so it should be talking to it at least. We'll make a quick check here as well.
Okay, that's an interesting observation.
We may have found a weakness.
Yes, we did.
This is what coach engineering is all
Cheers.
about. Yeah, exactly.
Not
Celebration
spotted
time.
anyway.
Yeah, where's the champagne? Okay, so it's up and running. It looks like it's happy. Let's give it a little ping and make sure it's looking properly happy. Yeah, good.
Awesome.
Looking happy.
They're the
now.
books, yeah.
Right. Let's run an experiment. So this is still kill DB. So kill DB, as we know, is doing Docker compose down, which waits until it's done it, which is good. And once that's ready, we should see a deviation. That's what I'm expecting. Yeah, it's trying to talk to the app with that new URL, and hopefully it'll either time out or it'll block, which is also a
Or
good
it
indication.
recognizes, okay, there's something, but it's the error page and doesn't recognize that this is not the...
It's not looking at the content, it's just looking at the return code. So it depends how quickly that return code's coming. This could be an
probably
interesting...
returning a 200, but with an error page.
It shouldn't be, it should be a 404. Boom. Took a little while, but the application tried to do its job and failed.
Okay.
So what we found is weakness. The application cannot survive database death in an elegant way. So then what you do is you go into Codebase, you make sure that all the interactions, or maybe up at the controller level, that's coming back with database dead, you capture that exception and maybe you return an error page. It's still a 200, but service not available right now, something more friendly. Because then that would still meet the promise of your steady state hypothesis.
Yeah.
So there you go. A couple of experiments.
Great.
What a weakness.
Awesome. And we are close to our 1 hour deadline that we
Yes,
set
I'm sorry.
to
Yeah.
ourselves. Yeah. Maybe you have to continue the roadshow.
And I'll make sure I
But,
commit these into the code base. So you'll have these experiments.
yeah, that's awesome, and then we can actually work on them. So I would like to fix that because. Quite bluntly, I have no idea how I will do that at the moment. So
Well, I might be able to help you with that. I'll have a look in
yeah.
the code base and see if there's anything we can do about what bubbles up from the DB.
Awesome. Well, thanks for being here, Russ. It was
My
a pleasure having you.
Thank you very much, sir. Cheers.
Cheers. And as always, if you have questions, please write them down in the comments. I can forward them to you if there's any. Or find you on Twitter. You're at Russ Miles.
Yes, that's the best way to
on
ask me questions.
Twitter.
Get my attention.
Awesome. And yeah, don't forget to. Oh, there's this outro slide here, like this. Okay. So don't forget to subscribe to the channel, of course, to don't miss the next episode of Let's Code or other conference talks or sessions that we are hosting here. And hopefully see you soon.
Thank you very much, everyone. Cheers.
Cheers. I have to find the button to